Okay, so let us start from where we left in the last session. So we are going to discuss on feature encoding. So what is that? It is basically we do some transformation on the categorical data. So categorical data means it is non-numeric data, and it can be of two types. It can be nominal or ordinal data. So we have to handle them differently. So suppose there is a gender column, so it can have the values male and female. So and it can be your grade in the exam, so that can be exceptional, very good, poor, like that. So the grade example, it is a ordinal data, right? Because if I assign some numeric values to that, so I can say that a exception is the highest order, and then comes the very good, and then good, like that. But for gender column, it is categorical data, but it is not ordinal, right? So I cannot order them like that. Okay, so for that we have to handle them. Actually, why I am doing feature encoding? Because I am trying to have some numeric value in the data of categorical variables, so that I can handle them, because in machine learning algorithms these values will be more acceptable than the categorical data values we have in the columns, right? So we will do that through some Python programming. So I will go back to my Jupyter notebook. Okay, fine. So here this is my data set. So I'm making a copy in ls1. Let us execute. Okay, so here I am grouping by gender column. So you can see there are two types of gender records. There are 258 female category records and 1760 male records. Okay, so now I am going here in sklearn.preprocessing. We are importing ordinal encoder. I'll tell you that ordinal encoder is actually for handling ordinal data, but now for this example I'll show you with first this ordinal encoder how it works. Okay, so here I have called this ordinal encoder. It is saved in this object encoder, and then I am calling the feed transform function for this ordinal encoder. Okay, so I am sending the gender column of this data set. Okay, so let us execute and see how it works. Okay, so it gave us some error. Why? Because you can see the value error, it is input contains NaN. That means there are some null values in this column, and when there is null value, then this encoder function cannot be executed. So to avoid that, first we have to fill those null values with some value. So here I have one value called missing, so I am just filling all the null records with this missing value. So let us execute. Okay, so now if I again execute the group by function, so you can see that now I have 258 female records, 1760 male records, and 245 missing records. So earlier case, there were these 245 records were having no value for gender column, it was having the null value. Now I have replaced null with this missing value. Okay, so okay, so before going to sklearn, I will show you that there is some way in pandas as well where I can do this conversion. Okay, values to some ordinal encoding, equivalent to ordinal encoding. So here I am calling pd.categorical, and in this function I am sending the gender column, the categories, okay, female, male, missing, and then ordered equal to true. So if you execute this, okay, so okay, so this, it actually contains the values in that order. Okay, and then here you can see as I have mentioned order equal to true, so here it is taking female less than male less than missing, so it is ordering the result in this way. Now this is here I am calling this factorize method. Here I am sending this cat and sort equal to true, and then these labels and unique are generated, and here ls1 dot gender equal to label. So these labels will be generated. So let us see how it works. So now you can see that these labels are generated 0, 1 and 2, and that is based on how I have sent. As female was sent first, that's why it is assigned to the value as 0, and then male is converted to 1 and missing data is converted to 2. Okay, so and again now so that is one way that I can do in pandas, but now I will see that how to do, because generally we will use this scikit-learn only. So I will again copy this to ls1. Okay, fine, and then I will fill the missing values. As you know that without filling the missing values this will give me error. So I will execute this. Now I am doing the grouping on this gender column. Okay, then execute this. So you can see this is how the records are. There are 3 categories of records now with these counts. Now I am doing again this ordinal encoder I am calling and doing the same thing for gender, and these categories, these encoder that categories will show you actually how the categories are created. So you can see that these are the 3 categories of records. Now if you just execute this again, so you can see that 0.0 for 258 records, that means the female is now converted to 0, male is converted to 1, and missing is converted to 2. It was done basically on the order of alphabetical order. This way it is given the values as 0, 1, 2. It's actually best fit for ordinal data. Okay, now if I want that, no, I don't want 0 for female, instead I want it in a different order, then I can change the order here. While I am calling the ordinal encoder, I will send that category is equal to this. Okay, so let us execute this. Okay, unsorted, okay, sorry, so it was already these values are present. So let us first copy it again. Okay, so I have these values. Now let me execute this. Okay, first I will execute this. Oh, sorry, let me first execute this one. So I have these 3 groups now. Now I will go here. Okay, so I have these 3 possible categories, and now in different order. Okay, I am sending missing, then female, then male. So if you now execute this, now you can see these 245 records are having the value 0, that is the missing value. So now this missing category is just transformed to 0, female is transformed to 1, and male is transformed to 2. So that's how I have just changed the categorical value to some ordered numerical value. Okay, so now I will take the category column. So there are 3 categories: general, SC and ST, and this is the number of records. Okay, so now as I told you that for even gender or category you cannot order the records like 0, 1, 2, because they are not ordered column, right? So I cannot give them the order that okay, this value is higher or this value is lower. So for those type of categorical values, that is the nominal attributes, for that we need to have some different type of encoder. That is in sklearn it is called one hot encoder. Okay, so for this category column I will use one hot encoder. Okay, here I am sending this category column, and and okay, fine, let us So I know that there are 3 possible categories, so I have given some 3 columns. I am just converting the data I am getting from this 1R encoder into a data frame. Okay, so let us first execute this. Okay, so one more thing is here I am adding one more column in this nominals in the data frame, where it will be just the category of this ls1. Okay, so 3 new columns and one more column. It will be more clear when I show the example, but here it is showing some error that input contains nan, because this category column also has some null values. So let us first fill the null values with some default value. So again here the value is missing. So if I execute, okay, now I will try it again, and okay, first let us group the records. So when I have grouped, I can see that there are now 4 types of categories: general candidates 1392, missing category 245, SC 383 and ST 243. Okay, so now what I am doing here, I am calling one hot encoder, and here I am converting these nominals to a data frame, and I am sending 4 column names. Okay, because when you are converting this array to a data frame, then you have to give some column names. So as 4 columns will be created. How it is done, I will show you. So let us execute this. Now if you run this, you can see that these are the column values. So you can see here that these 4 columns, some of them, 3 of them are always containing 0 and 1 of them is containing 1, like that it is populated. Okay, so here what I am doing in this, with this ls1, I am adding the nominals also. Okay, one more thing I will do, this will help. So I will do this step as well. Okay, now if you see the data, now you see the data that here if you see the data, you can see the actual category value was ST for this particular record. That's why for these 4 columns, if you check that only for this ST column there is value 1, and for rest of the columns it contains 0. Now if you see this record, here category is missing, and if you can see that only in this missing column there is the value 1 and rest of the values are 0. And now if you consider this column, this record, here the column value is SC. That's why here in this SC column there is a value 1, rest of the columns are 0. So how this one hot encoder works, that for all the possible categories it creates multiple columns, and in these multiple columns it keeps only 0 and 1s, and for the appropriate value of that category, for that particular column contains 1 and rest of the columns contain 0. So as there are 4 types of values per category, so there are 4 columns and all the columns contain 0 except for the actual value present. Okay, so this way one hot encoder works, and here I am not doing any ordering. That's why it is you cannot say that okay, this is higher order or this is lower order. So that's how we are handling the nominal categorical attributes. Okay, so now if you check the data, so these are the 5 categories of data, and now if you just, I am concatenating these nominals with ls1 with my actual record set. So now it is, concatenation is done, and now if you print the records, you can see with the original data set these 5 columns are also added. Okay, so this is how I have converted the categorical non-numeric data to numeric data, and I have handled nominal and ordinal attributes in different ways. Now we will move to discretization and binarization for numerical features. Okay, so now we will show the examples of discretization and binarization for numerical features. We have already discussed about it. Now discretization means when there are continuous numeric value, then I can put them in different number of bins and make them discrete value, right? Instead of continuous value, I'll change this to discrete value. I gave you the example of age. So if the age of a person may vary from 0 to 100, so it's a continuous value and there are a lot of possible values are there. So instead of maintaining that, what we can do, maybe we can create 10 groups, like for age 0 to 10 group 1, 10 to 20 group 2, 20 to 30 group 3, like that. So instead of maintaining numerous number of ages, I can have some 10 groups. So I can assign, whenever some age is coming, I will check that in which group it falls in, and accordingly will assign some value to it. That is the discretization. And binarization means it is like 0 and 1. So maybe I can decide that if the age is less than 50, then it will be transformed or changed to 0, and if the age is greater than 50, then the value will be 1. So that is what discretization and binarization are. So let us have some examples. So here I have imported k bin discretizer, and number of bins is 6, and encoding I am doing ordinal encoding, and strategy is uniform. Okay, and then this discrete equal to, I am calling the fit transform method for general votes column. So you know, general votes is a numeric column, but it is a continuous value. It can actually vary, and it can have infinite number of values from the 0 and the total number of votes possible. Okay, so let us execute this first. Okay, so now I am creating a data frame from this discrete, and I am giving the column name as general votes. So let us see how it has been created. So now I had ls5 just created so far with feature encoding. Now I am adding this data frame also. I am concatenating with ls5 and creating a new data frame, that is ls6. So let us execute this. Let us execute this. So if you see, there is a general vote column, and it is having some 1, 0, 2, 3, 4. These are the possible values. Okay, so if you see some more data, let us have some more data. So I'll see some. Okay, I see some 50 records. Let us execute. Okay, so actually there are 6 bins. So sorry. Okay, so actually as there are 6 bins, so I will be getting values from 0 to 5, all the possible values of 0 to 5. Okay, 0, 1, 2, 3, 4, 5. So the value which is in the range of that particular region, because total number of possible values are divided into 6 bins, and each bin is containing a set of values, and we are giving the value as 0, 1, 2, 3, 4, 5, etc. Okay, so as you can see that the values are from 0 to 5. So it is with discretization, what we have done, instead of the continuous values, we have created some 6 bins. So 6 possible values are assigned to that value. Okay, and as we know the rule, so whenever required, I can understand that okay, in which range this value falls in, because this discretization will help in executing the machine learning algorithms in a more efficient way. Fine. Now I am going to the binarizer. So binarization, I told you, it is a special type of discretization where we have 2 possible values, 0 and 1. So here when I am calling binarizer, I have a threshold. So threshold here is 30,000. That means that if the value of the column where I am doing the binarization, if the value is less than 30,000, then it will be assigned the value 0, and if it is more than 30,000 it should be assigned the value 1. So here I have taken the column total votes. So let us execute this. Okay, so now again I am creating a data frame from this, and I am giving the column name as total votes. So I have executed, and now I am concatenating ls6 with this data frame, and now let us see the data. Okay, so if you go there, you can see there is a new column is added with the data set where the possible values are 0 and 1. So from the continuous numerical value, I have created a binary kind of value where the possible values are 0 and 1. And for general votes column, from the continuous numeric value, I have put the values in 6 possible value sets. Okay, so instead of a continuous value, it has become discrete, and some 6 possible values are assigned to all of them. So I can, instead of using the actual columns, now I can use this transformed columns from my further processing. Okay, so we have covered feature encoding and discretization and binarization of data. For the other parts of data preprocessing, we will continue in the next tutorials. Okay, so thank you.